What you're looking at shouldn't exist. This lake, nearly 2,000 feet deep, appeared in a matter of days when an entire mountain collapsed 7,700 years ago. But that's just one of Oregon's geological secrets. From lava tubes that could swallow buildings whole, to a desert that appears out of nowhere in a rainforest state, Oregon hides some of the most extreme geological features in North America. By the end of this video, you'll understand the violent forces that created these wonders and why one of them is still a ticking time bomb. Let's start with number 5. Imagine walking through a tunnel carved not by water, but by molten rock flowing at over 2,000 degrees Fahrenheit. That's exactly what Oregon's Lava River Cave is, a mile-long tube created when the surface of a lava flow cooled and hardened, while the interior kept flowing, eventually draining away to leave this hollow tunnel. Located in the Newberry National Volcanic Monument, this isn't just any cave. At 5,211 feet long, it's the longest continuous lava tube in Oregon. But here's what makes it truly remarkable. These formations hanging from the ceiling aren't normal stalactites. They're called lava cycles, formed when molten lava dripped from the ceiling and cooled mid-drip, creating these bizarre, rocky icicles. The cave maintains a constant 42 degrees Fahrenheit year-round, making it a natural refrigerator. Native Americans used it for exactly that purpose, storing food and seeking shelter. But here's the unsettling part. Geologically speaking, 80,000 years is yesterday. This region was erupting lava, while humans were already walking the earth. And those eruptions, they're not done. Which brings us to number 4, a geological feature that looks like it belongs on Mars. Rising 600 feet above the Crooked River, Smith Rock looks like a fortress built by giants. These towering rock formations aren't just beautiful. They're evidence of one of the most violent volcanic events in Oregon's history. 30 million years ago, this entire area was buried under volcanic ash and debris flows from massive eruptions. Over time, the softer rock eroded away, leaving these incredibly hard, welded tuff towers standing alone. But what really makes Smith Rock unique is its composition. See those different colored bands. Each layer represents a different volcanic eruption. Scientists can read this rock like a history book, with each stripe revealing the temperature, composition, and violence of ancient explosions, the red and orange sections. That's oxidized iron from ash that was so hot when it landed, over 1,400 degrees, that it literally welded itself together. Here's the fascinating connection. Smith Rock sits on the eastern edge of what geologists call the high lava plains, a volcanic region that's been steadily marching eastward for millions of years. It's part of the same volcanic system that created features we'll explore later. But now, we're heading to one of Oregon's most contradictory features. Remember when I mentioned a desert in a rainforest state? Let's talk about number 3. This is the Alvord Desert, a 12 by 7 mile stretch of perfectly flat alkali playa in southeastern Oregon. And it shouldn't be here. While western Oregon drowns in over 80 inches of rain annually, the Alvord Desert receives less than 7 inches. It's one of the driest places in the Pacific Northwest. How is that possible? The answer lies in what geologists call a rain shadow. The Cascade Mountains act as a massive barrier, forcing moisture-heavy air from the Pacific to rise and cool, dropping all their rain on the western slopes. By the time air reaches eastern Oregon, it's bone dry, but the Alvord's flatness tells another story. 10,000 years ago, this desert was a 140-foot deep lake, part of a vast wetland system. As the climate warmed after the Ice Age, the lake evaporated, leaving behind this incredibly flat basin and concentrated mineral deposits. And see that massive escarpment rising behind the desert? That's Steen's Mountain, a fault block mountain that's still tectonically active, rising on one side while the Alvord Basin sinks on the other. After rare rainstorms, the playa becomes a perfect mirror, reflecting the sky so clearly you can't tell where Earth ends and heaven begins. It's temporary, lasting only hours, but it reveals why ancient peoples considered this a sacred place. Now, remember, I mentioned this region is tectonically active. That brings us to number 2, a mountain that looks peaceful but is anything but. Mount Hood. At 11,240 feet, it's Oregon's tallest peak and the most visible symbol of Portland. It's also one of the most dangerous volcanoes in North America. Notice those steam plumes? That's not snow melting. That's volcanic gas escaping from fumaroles near the summit. Mount Hood isn't dormant, it's resting. The USGS monitors this mountain constantly because of what happened the last time it erupted. In the 1790s, Mount Hood erupted violently, sending pyroclastic flows down its slopes and creating the distinctive crater rock formation you see near the summit. But here's the terrifying part. Over 300,000 people live in the path of Mount Hood's lahars, volcanic mudflows that can travel at highway speeds and bury entire valleys under tons of debris. The Sandy River, which flows right through Portland's eastern suburbs, is a natural lahar channel. If Hood erupts with significant ice melt, and remember, the mountain is covered in 11 glaciers, these communities have less than an hour to evacuate. Scientists estimate Mount Hood has a major eruption every 200 to 300 years. The last one was 230 years ago. Now here's where it gets interesting. Remember that volcanic system I mentioned at Smith Rock? Mount Hood is part of the Cascade volcanic arc, a chain of volcanoes stretching from California to Canada. And the most dramatic evidence of what these volcanoes can do is our number 1 feature. This is Crater Lake, the deepest lake in the United States at 1,943 feet. But 7,700 years ago, this wasn't a lake. It was a 12,000-foot mountain called Mount Mazama. What happened next was catastrophic. Mount Mazama erupted in one of the most violent volcanic events in North American history. The eruption expelled 12 cubic miles of magma, roughly 42 times more material than Mount St. Helens. In 1980, ash fell as far as Alberta, Canada, over 1,000 miles away. But the eruption's power wasn't the most remarkable part. Watch what happened next. With the magma chamber emptied, the entire mountain had nothing supporting it. In a matter of hours, possibly minutes, Mount Mazama collapsed into itself, creating a caldera over 4,000 feet deep. The collapse generated earthquakes equivalent to magnitude 7 or higher. The Klamath people, who witnessed this catastrophe, preserved the memory in their oral traditions, describing a battle between the chief of the above world and the chief of the below world, that island in the middle. Wizard Island formed from volcanic activity after the collapse, rising from the caldera floor in a series of eruptions. It's proof the volcano isn't dead, just quiet. But here's what makes Crater Lake truly special. Remember that striking blue color? Crater Lake has no rivers or streams flowing in or out. It's filled purely by rain and snowmelt, making it some of the purest water in North America. Scientists can see objects clearly at depths of over 140 feet. That's like looking down from a 14-story building and seeing the ground clearly. And yes, like Mount Hood, Crater Lake is monitored constantly. The volcanic system beneath is still active, with hydrothermal vents warming sections of the caldera floor. Here's the connection we've been building to Crater Lake, Mount Hood, and every volcano in the Cascades exists because of the same geological process. The Juan de Fuca oceanic plate is sliding beneath the North American plate right now, at about the speed your fingernails grow. As it descends, water trapped in the rock lowers the melting point of the surrounding mantle, creating magma that rises to form volcanoes. This isn't ancient history. It's happening right now, beneath your feet. From lava tubes to collapsing mountains, Oregon's geological features aren't just scenic overlooks. They're windows into the powerful forces constantly reshaping our planet. That lake we started with, it's not just beautiful. It's a reminder that Oregon sits on one of the most volcanically active zones on Earth. The question isn't if these forces will reshape the landscape again. It's when. If you found these geological wonders as fascinating as we did, hit that subscribe button. We explore Earth's most incredible natural phenomena every week. What geological feature should we explore next? Let us know in the comments. Thanks for watching, and remember, the ground beneath you has stories to tell.